Thank you very much. And we really appreciate the opportunity to present some information to this group. We would love to be taken for granted. If everything ran as smoothly as we would like, we can handle being taken for granted. The challenge is that not everything runs smoothly all the time. And the other challenge is, quite frankly, especially in this subject area, our researchers across this incredible campus are always pushing the envelope, right? It's not about using past technology to do research. They want to use future technology. And the great case study that reminds me every day of this is, there was a couple of years ago where everybody was pushing into 5G. And so the university has been pushing really hard to get 5G services up. We've got researchers pushing 6G and 7G. So there's never a pause in that push. One of the big drivers behind centralization has been to really focus on how do we use that centralization to improve things. And one of the best examples of what decentralized IT could sometimes look like is this picture. If you let a house get designed by 500 architects, you can have some mixed results. And so this really is sort of what my customers felt like in dealing with IT when it was distributed across 32 different IT groups. Our hope, obviously, is by bringing those resources together, we can accomplish a bunch of things. When we looked at what those challenges were, they really broke down into a series of things that need to be fixed. One, internal to the IT organization, how do we build careers, not jobs? When you work in a small IT shop with 6, 7, 8, 9 people, unfortunately, typically you can forecast your future with way too much clarity. It's a reactive type of role. You're fixing the same printer once a week. There's never enough time to really tackle anything big, to spend time looking at new technology before you have to implement it. And where do you go, right? You're part of a team. Typically, what we've seen historically is individuals would leave the team and go to another team at A&M, or unfortunately, they would leave A&M altogether. And so one of the things that President Banks really pushed hard on when we started this process was to build those careers. And we've been doing that within the organization. We've been building career paths, both technical and management, so that people that wanted to stay in the technical vertical could and didn't feel like they had to go into management to move forward in their careers. The other challenges that we've identified and we're working on are things like cost. We would buy 50 devices, but we would buy them in groups of 1. And so you'd have 50 individual purchases, not a purchase of 50. That meant that we were buying small and we were paying big. And that's not the right direction that we need to be going. So part of what we'll talk about here in a little bit, but part of what we're focused on is how do we flip that? How do we start buying, getting the vendors to recognize we're going to buy 1,000 units this year. We want the 1,000 unit pricing, not the 1 unit pricing 1,000 times. And so driving cost out of the organization is a huge part of what we're trying to focus on. As I mentioned, one of the challenges in a bunch of small groups is how do you have the resources to focus not only on current needs, but what the researchers and the teams are going to need in the future as AI or ML or VRAR comes forward. Having teams able to focus on being able to support that currently and then as the next generations of it come forward. Tackling long-term big projects like replacing the network on campus is almost impossible to do when it's 32 little groups. They are traditionally tend to be reactive in nature, very little proactive. One of the areas we identified very quickly was we had some fantastic student workers, and we had an HR policy that said you had to have 2 years of full-time experience before we could hire you. So we were graduating student workers that had worked for us for 2 and 3 years and telling them, we'll go out into industry for a couple of years and then come back. And that's a terrible message. So we fixed that. We can now hire our own graduates that we've spent a lot of time building. There were major security issues with 32 groups trying to do security. You had some that were good and some that weren't, but it was very inconsistent across campus. Fixing that makes security easier and better. And then just a lack of communication. Somebody would figure out how to solve a problem, but how do you share it with 31 other groups? So these are things that we've had to try to figure out a way to go fix. We're doing that, and we're focused on 5 major focus. One is on staff. How do we build that career path for both our staff, our future staff, and then how do we build the technical expertise up of some of these student workers so that if they were asked to participate in, for instance, undergraduate research, they would have the skill sets to bring to the table to make that a valuable experience. Customer service. We've got north of 15 different help desk systems on campus. We're going to go to one. And the intent of going to one is to get a consistency of service, but it's also to increase the quality of the service that's available. Right now, unfortunately, when you come into our help desk environment historically, you probably bumped into someone that was coming off of a "how do I help you" script. And many folks got asked, have you rebooted your machine? Have you turned on your machine? Is it powered up? Things that you've already filtered through prior to calling, but they were part of that script. And because we didn't know where individuals were coming into the help desk from, getting them routed back to somebody that could actually help them out and fix something was a challenge. And it might involve 2 or 3 connections. So part of what the new system is going to give us the ability to do is to know who's coming into it and say, oh, you're involved in this research organization. You're working on this. Here's the right part of the help organization to get you to faster. So being able to be proactive with delivering that, increasing the support for remote campus locations that where we understand the uniqueness of that remote campus and can fix things faster. The other side we got to focus on is delivering technology. Like I said, when it was 32 different IT groups, things got delivered in 32 different ways. And it was challenging to tackle big projects. We have a huge network refresh going on the campus. And that refresh involves expanding Wi-Fi coverage significantly is one good example. We're going from about 8,000 wireless access points on campus to over 20,000 wireless access points on campus. This will give us coverage that we've never had in buildings and outside of buildings. So doing programs like that, looking at how do we build technology around on-prem and cloud for use by researchers? How do we increase the technology coverage in classrooms? How do we build platforms as fast as technology is changing? I mean, less than a year ago, no one really had ever heard of Chat GPT and AI. Now you can't pick up anything almost without seeing some sort of communication about those products and how they impact our lives. Being able to be ahead of that curve, not waiting till it hits campus, but being able to have it as part of something we're doing with the anticipation that it will be coming to campus is very important. Specifically within the research areas, one of the areas that we've got to improve upon is helping the researchers reduce the time to starting research. They win the grants, they go after the grants and succeed in getting them. And then it takes way too long to get up and running from a technology point of view in those environments. And then the other big key of this is how do we help the research teams be able to spend more of their time doing research and less of their time doing IT. And we've got to build up our capabilities and our systems to be able to support them in ways that we haven't historically, so that they don't have grad students doing mainly IT stuff. They have grad students doing research. And so we're putting systems in place to do better ends of management around machines, to be able to streamline some of the workloads so that the workload doesn't fall on the research teams. It's handled by our organization. The other area that we're working on, and I talked about it a few minutes ago, around things like buying bulk volumes of things. We're launching a tech hub store that will allow us to forecast purchases and actually keep inventory of key systems on site. Because right now, one of the big challenges that our research teams in particular see is they place an order for a machine today, it comes in tomorrow. They place an order next week and it comes in a week. They place an order in the next week after that, it comes in 6 weeks. There's not a consistency from a supply chain and the ability to deliver product that there should be. So part of what we're looking at is identifying commonly ordered pieces of equipment and trying to have an inventory of those available on campus so that we can come back and say, if you can purchase from this list of solutions, then it's a 6 business day or 5 business day type of delivery system. Looking at software coverage is another good example. We've got, rather than buying software licensing 1 unit at a time, let's go do some common buying across software so that we get better pricing from the vendors. Having common solutions so that we're not creating Frankenstein systems every time we want to go out and build something. We can get repeatable processes in place. So these are things that we know we have to move forward on. Let's talk a little bit about how we're going to do that and where we see the biggest impacts, especially in your world as we move forward. As I mentioned, we're doing a complete refresh of the network. The network we're all operating on today was designed in the late 90s. It was designed based on the technology available in the 90s. Things have changed. Things like, I don't know, iPhones have come along. More and more of what we do is done wirelessly, not wired. So the new network design is a wireless first model, wired second, and that's a complete flip from the way we did things before. But it will let us now implement technology that we've never been able to implement. I list network segmentation because this gives us the ability to say, okay, I have 3 environments here. This one needs low latency but high speed. This one's an average environment. It can handle this type of latency, this type of speed. This one is a fairly slow environment and doesn't need to the extra levels. We can provide network solutions for all 3 of those that are different. We're not trying to make one size fit all. And that's historically what the network's been designed to do, is one size fits all across the environment. And that's just not realistic to how we need the network to work. The segmentation also helps us from a security point of view. You can have organizations that need high security environments, and you can have organizations that don't need high security environments running on the same network, and only apply the high-end security to those segments that need it. Obviously, the rate of new technology, especially now, feels like it comes at us faster and faster and faster. I mentioned Chat GPT because you can't do or say anything today without talking about it. AI, artificial intelligence, and machine learning have been around forever, right? Those of you that bought things from Amazon back in 2005 or whatever probably got a prompt from Amazon that said, "Woo, you just bought this. Wouldn't you like to buy these 3 things as well?" That's machine learning. That's artificial intelligence in use. It's been around for quite a while. What happened about a year ago is it suddenly hit that tipping point of becoming something that all of us can use without a in-depth technical knowledge. We don't have to be Amazon to utilize it. So we can all go to Chat GPT and have it do things for us. That accelerates that deployment of technology, that implementation of technology. Now it starts getting embedded in Exchange, or it starts getting embedded in Word or Excel or in chat boards and used by teams. Well, new technology is great, but we have to use it in a secure way, and we have to use it in an effective way. And we got to watch for law of unintended consequences as we do that. So getting prepared to support current new technology and future new technology is a huge task in facing us. Using it correctly is also important. So in the case of some of the artificial intelligence environments, people need to understand when you push your data into ChatGPT, you are providing that data to everyone that uses ChatGPT. So if you're a researcher and you pump your data in there, you've now shared your data with the world. We need to make sure that that education of that goes in. We need to build private AI environments for our researchers to use so that we protect our intellectual property. We protect the confidentiality of our data. We don't have people pumping FERPA data into public domain environments. So there's lots of things we have to be able to do both from a technology point of view and from a usage point of view to deal with that. One of the key areas that we have been focused on and will continue to focus on are things around storage and backups. Many of our researchers under their grant obligations have to retain their data for a period of time. We need to find ways to make that easier and less expensive. You shouldn't store an archival copy of something on real expensive disk. You ought to put it into very inexpensive disk so that you meet the terms of your grant, but you're not chewing up a lot of money to do that. And the amount of storage we need is radically changing. As research teams move from, age myself a little bit, move from writing things down in books to collecting electronic data, digital data at millions of records per minute, the amount of data you have to have or storage you have to have, it goes up exponentially. As people look at your cell phones, as your cell phones move from low resolution pictures to very high resolution pictures, the amount of storage needed for all of that moves up significantly. The other big area that we've worked on and continue to work on is differentiating between the types of environments, right? There are situations where we need machines on campus in the lab. There are situations where we need some of that gear there, but some of it can be cloud-based. And then there are environments that can be purely cloud. And being able to offer all three of those platforms to our research programs is hugely important. I talked a little bit about endpoint support, being able to take away some of the workload that is faced by the research teams in their labs. Common purchasing, we've talked a little bit about. Providing better support in the grant writing process. So that, and I know a lot of that process seems to occur at 11:59 p.m. for a 12 o'clock submission, but getting systems in place to better support those applications so that they've got a better chance of winning that grant is an area that we've got to focus on. Everything is increasing the security requirements. NSF is a good example. They used to have a pretty wide open view of security. They're now looking at some of the DARPA stuff. They're looking at some of the DoD stuff that's out there and including those conditions in those grants. We need to be able to make sure that our research teams are meeting those requirements, meeting the letter of the law and the law as they move forward. So security, obviously, for a lot of reasons, all of us experience it, but the research teams in particular are starting to experience more and more additional security requirements in the grant that they're receiving. And then, like I said, a lot of this is how do we work within the research organizations. You know, we're still trying to figure out how to consume 5G services. I've got research teams looking at 6G and 7G. How do we provide enough support so that they can do that? And it's, you know, that's a huge challenge in this process is what does that new technology need to look like? When will they need to have that new technology available to them? What environments does that new technology need to be into so that we can get there? So when you look at these programs in terms of things that we're focused on, these give you some ideas of how we're trying to focus the organization. Structurally within IT, we're trying to restructure our organization, all 32 unique units, into an environment that really has a driven component feature to it that says I move from engineering and architecture of new systems to the operation of those systems, to the delivery of those services. And so one of the questions we got a lot and was we started this process is, well, does that mean you're going to take away all the people that live in our group? No, that delivery of service is key and integral to how we're trying to structure the organization. We're trying to structure it in a way that those individuals provide huge value to the groups and need to remain in the groups. We want to try to be able to help them move their workload from almost purely reactive to partially reactive and more proactive in nature. Part of the way you do that is you automate things that used to be manual, right? So patching of machines, for instance, can be automated. Doing that frees up resources that then can be spent on proactive work within the groups. Going out and working with a research team for 6 weeks, because that's what it takes to help them get up into research faster. That frees up those resources to be able to do that. So, and quite frankly, from a Groundhog Day syndrome, it helps our staff out. They're not fixing the same printer every week. As exciting as that was the first time, by number 100, it gets a little boring. So taking out some of that kind of workload and centralizing it, providing multi-platforms of storage so that we don't try to make one size fits all. But this is, organizationally where we're trying to go. We're centralizing those features and functions that make sense. We had a lot of teams out there that had software development embedded in their local team. Well, it would be 1 or 2 people doing software development. Having them part of a group of 10 or 15 or 20 people doing software development makes sense because they get to have unique skill sets they develop that marry and partner well with other groups that they're working with. So structurally, we're trying to move to that type of model to really focus on how do we deliver services, how do we work within the services that are available. For instance, we have an incredible high performance compute environment. How do we do a better job of, from an IT point of view, of helping our customers know when do they take advantage of that environment? How do they take advantage of it? Who do they get in touch with? When does their research become at a level that it can really benefit from those types of resources? So that's a consultative type of relationship that we've never historically really been able to focus on. We're now taking staff and allowing them to build that expertise so that they can deliver that service and not be focused on break fix as much. Key to this is hearing what you need, what our customer needs. This is something that it's been a little surprising to us is, we thought we would get an unlimited amount of feedback. And we have in some areas, but we're still looking for what's the low-hanging fruit. If you could fix these 3 things, my job, my life, my group's life would get better. So we're looking for that feedback from you. And that's part of the process is, so help us provide that feedback, right? Where do we need to focus our attention to get the biggest bang for the dollar? This group and today is mission critical to that process. You see more of the organization than almost anybody else does. How can we make things better? What's your dream? If you could fix this, that would make my life better. Helping us get that list and prioritize that list is huge to our being able to do what we want to do. Well, I appreciate all of your time today. I really do. Like I said, it's not a one-time ask. If you think of anything, if you got questions, if there's ever anything we can do to make life better, please share that request with us. Let us know what we can do. We're here to support the incredible work that this team and other groups like you do in the university. So help us do that. Let us know what you need when you need it. And even if it's just a prediction of the future, I think we're going to need X in the future, because I'm talking to folks producing grants coming up. Let us know what intelligence sources you got and what we need to be prepared for, right? We don't like to be blindsided with this. We want to be able to, if someone comes to us and says, I need 6G X, we want to be able to say, of course you do. We thought you would 3 months ago, and we've already lined up the resources. We got to have a little bit of a crystal ball. So anything you can do to help us with that would be really appreciated.